The second part of the previous exercise, we did a comparison of 4 means using a Tukey procedure, and let's estimate the mean distance traveled for balls manufactured by the brand with the highest rank. Actually, from the StatCrunch result, we have all means. On my data, we have 40 balls, 10 for each brand. The highest value is 269, correspond to the brand C. Let's construct a confidence interval for the distance that this ball travel when it's hit by the robot iron belong. Remember, we studied this in chapter 7. The confidence interval is constructed using a t-student distribution, and the confidence interval for the true mean for all population of brand C is a value close to 269. It's approximately 270, but let's construct the confidence interval for this value. That is the formula. In this formula, this is the mean of my sample, 270 approximately, and this is the t-score, the value. This is the standard deviation of my sample. This is 1 divided by a square root of n, s divided by a square root of n. That is the formula that we studied previously. We have n, which is 10 ball. We use 10 ball to obtain this mean, and the standard deviation. Despite we can obtain the standard deviation from this 10, we have a better estimator of the standard deviation using this 40 ball. And we can use this standard deviation from the standard error. This formula for the standard error is given in this table. This mean square error is the variation of all value when we disregard the treatment. To compute this value, we use all 40 balls, and the degree of freedom is given by 36 because we compute the deviation with respect to the corresponding means. Then we use 4 means to compute this standard deviation. Then the degree of freedom is 36, 40 minus 4 means. And this critical value must be computed using finding in the table or using technology what is the area that corresponds, or the probability that corresponds to this tail, 0.25 in one tail. That is the variance, and the square root of this variance is the standard deviation. And let's substitute all of this value, n equal 10, s square root of 21.11, 0.17 is 4.6 here, and the only thing that is missing is the critical value. The critical value is approximately 2. How can we find this critical value? We can use technology or we can use table. Let's do it in both ways. If we use a table, we need to enter through the confidence interval. We want 95% confidence interval for this mean. The confidence interval for this mean is 95%. Then if we have 95% confidence interval, in 2 tail we have 5%, in 1 tail is 2.5%. And the degree of freedom for this distribution is 36. Then we enter through 95 and through the degree of freedom 36 to find the corresponding critical value, 2.028. That is the critical value associated with this tail, 0.26% on the right. And we can use technology also to find this critical value. We need to go to calculator in StatCrunch. In StatCrunch, we select t-distribution calculator. Then we use a standard, only one side, and that is the critical value that we need to find. The area on one tail is 2.5%. We need to input the degree of freedom here. This area in this box, we select here greater than, and we can compute. Let's do it. Then that is the critical value that we're going to find. We want to find 36 degree of freedom in this box, 0.025, the area on the right. On the right, we select this symbol and we click compute, and we obtain the same value that we got it in the table. That is the critical value in our formula. That is the formula. We have all value. We substitute all of this value in this formula. This is approximately 270. Actually, it was 269. And that is we round also the critical value. And this is the standard deviation. And we have 1/10, which is 0.10. And when we compute all of this result, we conclude that the distance traveled for branch C is at least 267 or no greater than 272. Is any value between these values. It's not far away from this value. Actually, we can use 270 to estimate this distance. And that's it.